Ah, Good morning, students. Okay, today we'll start our first lesson of 12th, rotational dynamics. Okay, rotational dynamics very important lesson for entrance as well as board. It is mainly divided into two sections. One is circular motion and second one is the rotational motion. One is the circular motion and second one is the rotational motion. In old syllabus, these two were the different chapters, but in your new syllabus two chapters are included or combined, and it forms only one chapter, that is rotational dynamics. Okay, this circular motion consists of six main topics: basic definitions, then uniform circular motion, centripetal and centrifugal force, angle of banking, conical pendulum, and vertical circular motion. Okay, again I will repeat, it is divided into six sections. One is the basic definition, second is the centripetal and centrifugal force, angle of banking, conical pendulum, and vertical circular motion. Okay, so this first we will see what is the difference between this circular motion and rotational motion. Circular motion means this, suppose this is the circle and motion of the particle along circumference of circle. Motion of the particle along circumference of circle is called as the circular motion. Means example, when you go for running practice on the ground and travel along the running track. Okay, so this is the example of circular motion. म्हणजे ग्राउंड वर गेल्यानंतर आपण जो राउंड मारतो तो कशा एक्झाम्पल आहे, सर्क्युलर मोशन. Okay, so this circular motion is performed by object or this any particle, and rotational motion is performed by the rigid body. Rotational motion is performed by the rigid body. Okay, when the rigid body, suppose this is one rigid body, and rigid body is performing rotating about an axis of rotation. Rigid body is rotating about an axis of rotation, then its particle perform circular motion. Okay, so later we will study this rotational motion. First we will study the circular motion. Okay, first we will see the basic definitions. Okay, this first we will see circular motion. This circular motion of the particle along circumference of circle. Suppose this P is the position of particle and particle is moving along this circumference, then it is performing circular motion. This circular motion is again divided into two sections. One is the circular motion in the horizontal plane, and second one is the circular motion in the vertical plane. When particle is performing circular motion in the horizontal plane, then the axis is in vertical plane. Circular motion is performed in the horizontal plane, then the axis is in the vertical plane, and when circular motion is performed in the vertical plane, then the axis is in the horizontal plane. Okay, understand? Two circular motions, one is the circular motion in the horizontal plane and circular motion in the vertical plane. Okay, majority of the section of circular motion, it is in the horizontal plane. Okay, now we'll see definitions. First definition, circular motion, the motion of the particle along circumference of circle. Examples of circular motion. First example, motion of electron around nucleus. Second example, motion of moon around the earth. This is second example of the circular motion. There are a number of examples, you have to remember these two: motion of electron around the nucleus, and second is the motion of moon around the earth. Okay, if you consider the clock, then this is, suppose minute hand or second hand. When it is traveling from one point to another point, okay, it is traveling from one point to another point, then whole hand performs rotational motion. Whole hand performs rotational motion, and the tip of the hand performs circular motion. You have to remember, this is the important sentence for entrance. When hand of the clock performs rotational motion, hand of the clock performs rotational motion, then total hand performs rotational motion, but the tip of the hand performs circular motion. Tip of the hand performs circular motion. Okay, this is the difference in case of this motion of hands of clock. Okay, now we'll see definition. Next definition, time period. Time period. The time taken by particle to complete one rotation. The time taken by particle to complete one rotation or revolution is called as the time period. It is called as the time period. The time taken by particle to complete one rotation is called as the time period. Okay. Then frequency. Frequency, it is denoted by different letters N, F, or this letter is nu. Okay. In formula, it is a reciprocal of the time period, and you can define it as number of rotations completed in 1 second. Number of rotations completed in 1 second is called as the frequency. Okay, you can take down the notes slowly by watching this video. Okay, the number of rotations completed in 1 second is called as the frequency. Its SI unit, there are a number of units. One is the hertz, second RPS, revolutions per second, then CPS, circles per second. When in problem it is given frequency, it is equal to suppose 2 RPM, revolutions per minute. In order to convert from RPM to RPS, you have to multiply it by 60, so that it will give you 120 RPS. You have to remember this conversion factor, converging from RPM to RPS multiplied by 60. Okay, RPS is the SI unit, RPM is not SI unit. Getting the point? Up till we have studied basic definitions of the circular motion, then time period and frequency. Now we see another basic definitions. This is the center, and this vector is called as the radius vector. This vector is called as the radius vector. Okay, initially particle is at A, and in time, small time dt, or you can say time t, particles travels from A to final position B and covers small angle d theta. This is AB. It is the arc length. AB is the arc length. So angular displacement, definition of angular displacement, this O is the center, particle is moving in anticlockwise direction. So the angle made by radius vector, at the center of circle, angle made by these two are radius vector. This is also radius vector, OA is radius vector, and OB is also radius vector. So the angle made by radius vector at the center of circle is called as the angular displacement. Angle made by radius vector at the center of circle is called as the angular displacement. Formula, basic formula for angle equal to arc divided by radius, symbol theta equal to S upon R, or small angle d theta equal to ds divided by R. Okay, you can write ds equal to R into theta. The SI unit of this angle, is radian. And its dimension, it is dimensionless quantity, means you can write L0, M0 and T0. Angle, it is radian. Okay, you all must remember the converging from degree to radian. Then what we'll do? Converting from degree into radian, then we can multiply by degree to radian. Okay, degree to radian, then multiply by pi by 180, so that it will be converted from degree into radian, and converting from radian into degree, radian into degree, then multiply by 180 by pi, so that it will be converted from radian into degree. Okay, now we'll see 1 radian equal to how much degree. Suppose particle completes one complete rotation, then angle subtended will be equal to 2 pi radian, and in degree it is 360 degree. So 1 radian will be equal to 360 divided by 2 pi. Approximately 1 radian equal to 57.3 degree. This question is asked in CET for 3-4 times. You have to remember this directly formula, direct relation, direct number. 1 radian equal to 57.3 degree. Okay, now we have covered this angular displacement. What is the definition? Angular displacement: the angle made by radius vector. Angle made by radius vector at the center of the circle is called as the angular displacement. Formula: theta equal to s upon r. SI unit radian, and it is dimensionless quantity. And you have to remember the relation: 1 radian equal to 57.3 degree. Okay, we will move next to second part, angular velocity. Angular velocity, it is denoted by this Greek letter omega. Angular velocity is denoted by letter omega. Simple velocity, what is the formula for simple velocity? Velocity equal to displacement upon time, displacement upon time. So angular velocity, just write angular here, again angular here. Angular velocity formula: angular velocity equal to angular displacement divided by time. This angular velocity, it is denoted by letter omega. Omega equal to theta by t, when you can also write d theta by dt. Omega equal to d theta by dt. When it completes one rotation, omega equal to this angle becomes 2 pi, and total time is capital T. This, but 1 upon t equal to n. So another formula for omega, it is 2 pi n. So you have to remember all these formulae: omega equal to theta upon t, omega equal to d theta upon dt, omega equal to 2 pi by t, or omega equal to 2 pi n. Its SI unit is radian per second. SI unit is radian per second. Okay, SI unit is radian per second, and its dimension L0, M0, T minus 1, and this angular velocity, it is a vector quantity. It is a vector quantity, means it is having direction. It is having direction. Okay, so the direction is given by right hand thumb rule. Direction is given by the right hand thumb rule. Okay, now we'll see how this right hand thumb rule is stated. Right, in case of right hand thumb rule, there are two important points. One is the stretch thumb, and second one is the curl fingers. Okay, curl fingers, you have to consider the curl fingers from bottom to tip. Okay, remember stretch thumb and curl fingers. Okay, suppose this line, it is the axis which is held in right hand. Axis is held in right hand. If curl finger shows particle is moving along the circle, imagine that axis is held in the right hand. The curl finger shows direction of rotation. Then stretch thumb gives direction of angular velocity. Getting the point? When the curl finger shows the direction of rotation, then stretch thumb gives direction of angular velocity. Okay, now we'll see. If you have to note down, you have to remember and learn all the formula by heart. Okay, now we'll see the direction. Suppose the particle is moving in anti-clockwise direction. Okay, particle is moving in anti-clockwise direction. In this way, then the stretch thumb is in the upward or outward direction. So omega is upward. When the direction of rotation is anti-clockwise. Then direction of angular velocity is upward. Direction of angular velocity is upward. Okay, now if particle is rotating in clockwise direction, particle is rotating in clockwise direction, then the stretch thumb is in the downward direction, so direction of angular velocity, it is in the downward direction. Direction of this angular velocity, it is in the downward direction. Okay, now we'll revise all the topics which we have discussed in today's this short video. First, this rotational dynamics, it is divided into two sections. One is the circular motion and second one is the rotational motion. Okay, this circular motion, it is performed by the particle. एक्झाम्पल तुम्हाला सांगितलं मराठीत आपण एक विनोदाचा थोडासा भाग बघू. ज्यावेळेस आपण ग्राउंडवर राऊंड मारतो त्यावेळेस ते काय होतं, सर्क्युलर मोशनचं एक्झाम्पल आहे. सर्क्युलर ट्रॅकला तुम्ही जर राऊंड मारला तर ते काय होत असतं, सर्क्युलर मोशन. आणि आरती म्हणताना ज्यावेळेस तुम्ही काय करताय, घालिंग लोटांगण करता त्यावेळेस ती कसली मोशन होत असते, त्यावेळेस ती रोटेशनल मोशन होते. ऍक्सिस भोवती गोल फिरणं त्याला काय म्हणायचं, रोटेशनल मोशन म्हणायचं असतं. ओके, सर्क्युलर मोशन मध्ये बरेच पार्ट आहेत. त्यातला फर्स्ट पार्ट तुम्हाला सांगितलं बेसिक कन्सेप्ट, बेसिक डेफिनेशन. दुसरा होता तुमचा युनिफॉर्म सर्क्युलर मोशन. तिसरा आहे सेंट्रिपेटल आणि सेंट्रिफ्युगल फोर्स, सेंट्रिपेटल आणि सेंट्रिफ्युगल फोर्स. चौथा आहे तुमचा अँगल ऑफ बँकिंग. पाचवा आहे कोनिकल पेंडुलम आणि सहावा आहे व्हर्टिकल सर्क्युलर मोशन. असे 6 सेक्शन्स आपल्याला कशाच्या अंडर, सर्क्युलर मोशनच्या अंडर शिकायचे. त्यातला आपण बेसिक पार्ट चालू केलेला आहे. त्यातली डेफिनेशन बघितली होती तुम्ही. सर्क्युलर मोशन, सर्क्युलर मोशन साधी सिंपल डेफिनेशन, मोशन ऑफ द पार्टिकल अलॉंग circumference ऑफ सर्कल. टाइम पिरियड, टाइम टेकन to complete one rotation. Frequency, number of rotations completed in 1 second. Number of rotations completed in 1 second. Then angular displacement, angle made by radius vector at the center of the circle. Angle made by radius vector at the center of the circle is called as angular displacement. And then angular velocity, the rate of change of angular displacement with respect to time. The rate of change of angular displacement with respect to time. And this angular velocity, it is the vector quantity. Its direction is given by right hand thumb rule. Curl finger gives direction of rotation and thumb gives direction of angular velocity. When direction of rotation is anti-clockwise, angular velocity is upward. When direction of rotation is clockwise, angular velocity is downward. Okay, you have to learn all these things by heart, and in next video we will complete the further part. Okay, thank you friends. Study properly, make your timetable for all subjects. Okay, thanks.